Music is an art concerned with combining vocal or instrumental sounds to make an emotional expression. Math is defined as a formal science and a precise science that studies the attributes and the relationships that are established between abstract entities based on logical principles.
It is not credible to say that math is everywhere we go, and also in music, and you might be wondering how. There are certainly undeniable similarities, such as the fact that both are so abstract that they seem to belong to another world, and also that they still having a great power in this.
Music affects the listener, and mathematics has multiple practical applications. One part of mathematics studies numbers, their patterns and forms, and these elements are inherent to science, composition, and the performance of music.
In a specific way, we're going to explain how the music and math get along with a diatonic scale. The objective, in a general way, is to explain the relationship between music and math and how they get along.
A musical scale, as we know, is attributed to Pythagoras, a Greek philosopher and mathematician who lived around 550 before Christ. Legend has it that Pythagoras listened to the hammer of a blacksmith hitting the anvil and found that the tones produced by the hammer were related to the weight of the hammer, and to his great surprise, the weights came together in simple integer radius. After further research, it didn't take long to him to realize that the consonant sound, tones that sound pleasant to the ear when played together are in the simple relation to each other. There are two assumptions when trying to create the Pythagorean scale. Or scale will consist of a series of notes, or scale should contain notes that produce a pleasant sound when played together, which means that the frequencies of the notes should be ensemble.
Okay, each of these dots are frequencies. These frequencies are the fifth of this one, and this of this one, and this of this one, in order to create a new note. When we have a scale of notes or frequencies that are symmetrical and will form a regular star, we will have created a scale that is nice to the human ear. Okay, as you can see, this is a regular star, and this scale sounds like this. And in particular, this scale are the pentatonic scale by Pythagoras.
Okay, so I'm gonna tell you what the harmonics are. The harmonics are one of the parameters that generate the characteristic timbre of a sound source. For example, a guitar, a fiddle, or our own voice. To make it easier to understand, I'll use my guitar and its strings as an example. When we make a string vibrate, it generates a musical note, which this musical note is conformed by various harmonics. The most important one is the fundamental. To explain how the fundamental works, try to imagine a string that vibrates and it has a crest in the middle and it vibrates like up and down, up and down, up and down. The second harmonic is basically the same as the first one, but it has two crests and it vibrates like a wave. And the third one has three crests, fourth one has four, and so on and so on. Knowing this, we can say that when we play a string, we're playing all of its harmonics at once, but with different volume.
The only material you will need to do this experiment is a piece of string. The first thing you will have to do is to tense this string. You can do this by tying it to something or just asking someone else to hold it for you. Then you will have to play it twice, one with the full length of the string and another with just the half. You will see that both sound pretty similar. Finally, you are going to play it one last time, but this time with 2/3 of the string. You will notice that it sounds different than before.
My name is Emma, and this is my partner Sosa.
Hello?
And we are from Team 1, and we're going to explain mathematics and music. Our experiment is based on strings.
So, in this experiment is based on the string theory that the ancient Greek discovered. This theory said that if you cut the string of a guitar into a half,
you are going to get the same note that the string has, but with a higher or lower intensity. The funny fact here is that if you cut the string into 2/3, you are going to get a new note. Yes, a new note. So this experiment is mainly to confuse the tune of Guitar Tuna. We are going to get confused and up. Human is better than robots. So please, Emma, play the fifth string. As we can see, the fifth string is represented by the letter A. So now, Emma, please play fifth and in the second plate. We are getting the same note, but in this case, we are getting in a lower intensity. Now, Emma, please play the fourth string. It is represented by the letter T. But here is the funny fact. Do you think Guitar Tuna is getting the same note when we play it? So please, Emma, 4th and 5th plate. Another time, please. 4th string and 5th plate.
Yes.
There it is. We are gaining a new note that it is G. It is the third string. You can see. And we get confused. The Guitar Tuna J. So this is all for us and for you. Okay. So see you.